So hi everyone, welcome to the Backend Development workshop. So the idea is if we can't explain something to a 5-year-old, it means we ourselves don't understand it. A lot of times we look at some backend concepts and we say it's very technical, it's rocket science, and we ourselves, sometimes suffer from it. But what if we can look at the entire backend in such a simple way that it becomes very easy to go and start working? Okay. So, because I think one difference between backend and front end is I think the number of lines of code which you write on the backend is usually a lot lesser than front end. But then, why is it that very, very few beginners get into backend? A lot of beginners go into front end, right? I mean, a lot of beginners get intimidated by backend. But backend is actually a little easier than front end in the sense that, I mean, when I was trying to get into development, I was like, front end is scary, yeah. Let me try backend. I mean, I enjoy front end, right? The aesthetics, the user experience is all fantastic, but I'm like, what the hell? 1,000 lines of code, who's going to write it? Go to backend, like 40, 50 lines of code and you're done. But the reason why I think a lot of people get a little intimidated by backend is, the first day when I went and I sat with Shravan and I was like, explain me how this thing works. And we were looking at his code. He's like, Dharman, this is so easy. This is so simple. I'm like, what easy? This is a Maya Jal. It's such a trap. There's so many things. There's so much which is happening over here. So the challenge with backend is really the system. Once we understand the system, actually writing the code is not very difficult. Right? And anyway, code can always be copy pasted from here and there. And as you do more practice, you'll sort of remember a few things. But initially doing copy paste is okay. So then what becomes the most important concept? If I'm saying that the number of lines of code is less, and if I'm saying the syntax can be copy pasted, what becomes the most important concept then?
The logic what to copy.
Correct. You'd want the logic, right? And so you know where to copy. But to get the logic, what becomes important? Why is the logic getting difficult in backend compared to front end? Yeah.
To recognize what we actually need, and for that to have the basic understanding.
Yeah, go ahead.
Means go to surface to in the deep so that you will get the core idea.
No, in front end also you need to go deep.
Yeah. In both the situation we need logic.
Because in back end there's so much of flow, right? Things are going across different places. So if you know the entire flow of where is it starting, where is it going, why is it going that way, then I think it becomes easier to understand backend. Now, before you understand backend, okay, let's do a Socratic investigation of the backend. Before you understand backend, you need to ask, why do I have a backend? Then what's the next question you would ask? Why a front end and a backend? Where does that answer lie? Why a front end and a backend?
By the websites we have.
Websites are fine. Okay. Why do you have websites? Okay. Why separate client and the server? Exactly, right? That's a fundamental question. So where does that answer lie? It lies in one paradigm of computation, which is called cloud computing, right?
Cloud computing.
Why do you want certain resources in the cloud? Why do you want certain resources in the cloud and certain resources in the client?
Data.
Sorry?
Data.
But why can't you have your data on your local PC, right? I mean, like how you run your Microsoft Office, how you run your Zoom.
But that won't help, no? There is like piles of data in bulk, and how do we manage
you
that?
Store your own data.
It will be not optimized.
Cloud. Yeah, it won't be that.
Why won't it be optimized?
Because, sir, so that user can get a better experience.
Why? I mean, Adobe software, Microsoft, all of this gives you a very good experience, and you have them running on your local machine.
Their servers are so fast.
Okay. So one, you're talking of the client's computing infrastructure.
Yeah.
Your PC, your mobile phone which you're using may not have that much of computing infrastructure as much as server might have.
Yeah.
Correct? A server has
Yeah.
access to more computing infrastructure. Okay, apart from computing infrastructure, what advantage do we get by getting something on the cloud?
The storage.
Yeah, the storage. You
Storage
won't
and
have to
computing
save it locally.
infrastructure. Okay, apart from the hardware, forget the hardware. Apart from hardware, what?
Flexibility to work from anywhere.
Flexibility to work from anywhere. Okay, fair enough.
Yeah. And to handle many users at a time.
If you're running it on a client, you can, you're running your own stuff, right? Why do you, I mean, you give out one copy to every client and every client runs it? Like Adobe, right? You just give a license and every client runs it on their own PC. Why would you want cloud computing? One, you said, storage. One more, you said computing infrastructure. Third, you said flexibility to work from anywhere.
We can get our data from any device.
Yeah,
That's what is said, flexibility to work from anywhere.
Flexibility.
Do you see the advantage of network effects? Do you guys get what I'm saying? Network effects.
What is
As in,
No, I don't.
now let us say Akansha is running her Adobe Photoshop from her PC and Abhishek is running his Photoshop from his PC. Now, can Abhishek then see how Akansha has made use of one feature very well to create a good picture on Photoshop? If they're all running on their own PC.
No.
Unless all those PCs are interconnected by internet and there's some protocol which will make all of them communicate with each other.
Hmm.
But what if Adobe has something called Adobe Cloud and all the data comes to the server and from the server it comes there? Then can we interconnect the experience of different users?
Yeah.
So then,
Yes.
okay, or let's see a simple.
So you're talking about collaborative experiences.
Correct. Collaborative experiences can happen on the cloud. Network is, yeah, one thing about, see, I think network is a little beyond collaboration. It's like, think about it. You guys were doing your assignments while getting selected to Deep Thought, right? You guys were doing your assignments while getting selected to Deep Thought. So you guys go and share your assignments on the WhatsApp group. How would that be different from you getting your own Google form and submitting your own personal Google form? Versus you all sharing your assignment on a WhatsApp group. Would you be able to learn from others' assignments?
No, Google form we don't have access to.
Yeah.
But if you're sharing in a WhatsApp group, you can see how others have done it.
Obviously.
Would you be able to solicit questions and feedback from other people who have done the assignment along with you?
Yeah.
Yeah.
You can ask people, hey, what's the feedback and so on. So the network effect comes in, right? So the entire network can come in and the network can add value in different ways. And people who like it will start sharing it. The idea starts spreading and so on. So when you bring in the cloud mechanism, there's so many benefits which come in, right? That's when we moved away from a software which runs on your own machine to a software which you run from the cloud. And if you think about it, I think Microsoft in the last several years, that's what they pioneered, right? Where they said you may be using your mobile, you may be using your laptop, you may be using your desktop, and we want to give one experience for you for your operating system all through. And today you have the Office 365 and you've got the Microsoft Cloud, right? So you have the same Microsoft account and you can open it from multiple, devices.
Yeah.
And you have Microsoft Cloud through which you can access all of them. And you think about it, all the big guys, Google, Microsoft, or Amazon, all of them have been talking of the cloud for quite some time. I mean, it's been more than a decade since everyone has been talking of the cloud. So this is the power of the cloud. So when we talk of front end, back end, I think it comes from this concept. Now, I'd like to take you through another important concept, which is industrial revolution. When you talk of cloud computation, even before cloud computation, you probably talk about digital revolution. If you make everything digital, What is the advantage? Now, let us say, I mean, I use this example in all my workshops. Let's say you're a hospital in the US. There's a patient who is critically ill. There's a patient. Yeah, Google Doc is also an example of cloud, right? That's exactly why Deep Thought is a huge fan of Google Sheets. You bring the power of cloud and you collaborate through the cloud. Again, the network effect comes in. So now, yeah. So now I'd like to go back. So we said cloud computation is powerful. Now we'll go back to digital computation. Now let's say you're a hospital in the US, right? You're a hospital in the US and there's one patient who's critically ill and you're in a suburb, right? I mean, there are not many doctors available there, right? There are very few doctors available there and your one doctor is at home and is sleeping. The doctor worked, let's say, for 15 hours and just went home at 2 o'clock and is sleeping, and it's 3 o'clock and the patient is critically ill. But you can at least make sure the patient is doing fine until the next doctor comes. When the same doctor comes back next day at 8 o'clock in the morning, when he catches up with some sleep. You've got a nurse there. The nurse can implement any protocol, but her problem is she doesn't know what to do. If she's told what to do, she can do it. What can you do then? The doctor is sleeping. The doctor can't be coming. And even if the doctor comes, the doctor will not be able to do a good job because the doctor worked 15 hours. What can you do?
Video call to that doctor.
The doctor is sleeping.
The doctor is sleeping.
Yeah, but like to get the data.
Yeah, but
Then we can certainly connect
you
with some
call
other doctor.
you call to another doctor maybe.
yeah, you call to another doctor, maybe in India, because it's morning in India.
There could
Yeah,
be
I mean,
advanced.
video call another doctor and get their advice, and then you tell the nurse what to do.
Exactly, right?
Yeah.
This is the power when something can go digital, right? Because what was localized to one place can then be done anywhere else in the world.
Obviously.
There's a book called The World is Flat. The World is Flat by Friedman. The World is Flat by Friedman. He explains the BPO revolution. The BPO revolution. There were a lot of BPO jobs which got created. It was because of this digital revolution. So let us say you're a CEO in the US. It's night, 10 o'clock in the US, and next day morning you have a presentation. You just finished all the points and you need a presentation by the next morning. Again, you can apply the same concept, right? You make it digital and anyone anywhere in the world can make it. Autopilot is a little different. So here I'm saying the moment you make something digital, that work can be done by somebody else somewhere else.
Okay.
Let's say you're a teacher and you want to correct some you want to correct some students' papers. The moment the papers get digital instead of on paper, that evaluation can be done by some other teacher somewhere else. Yeah, globalization can happen. Digitization can lead to globalization. So we said cloud computation gives them benefits, but we said even before cloud computing came in, digital revolution came in. And these are the benefits of digital revolution. And that's also one reason why we want to capture data and store data somewhere. That's again a reason why backend becomes important. Backend becomes important because you want this concept of cloud to come. Backend also becomes important because you want to have digitization of the data so you can perform that activity somewhere else. Why you run multiple clients, right? So one could be your client who's paying for you, another PC. So you have a business wala client who's giving you the job. You take it to your server, then you give it to the worker who's doing the job. You take it back, then you give it to an auditor who will check whether the job is done well, and then you deliver it to the client. Say I'm the server. Chandrasekhar is my client. He says I want a PPT. I take his requirements. Then I go to Sumit, who's my project lead. Sumit looks at the requirements. Sumit tells me whom to allocate. I take it. Then I go to Shafiq, who's the one who will work on the project. Shafiq completes the project. I take the project server. I give it to Sumit. Sumit checks if the project is okay. Then I deliver it to Chandrasekhar. I take his feedback. I give that feedback to Sumit. I give that feedback to Shafiq. So with the power of the cloud and with the power of digital data, I'm able to coordinate three people really well.
Without manually contacting them.
Yeah.
Right. So Yeah, 1 minute. I'll just create the thread builder link.
What is thread builder?
Yeah, so we use a software in Deep Thought called Thread Builder, through which you could be, listening more mindfully. So people in Deep Thought usually have the habit of thread building while participating in any workshop. So yeah. Just 1 minute. Yeah, so yeah, what was I speaking of? I was speaking about cloud computation, and then I was speaking about digitization, right?
Yeah.
Yeah, so the thread builder is now live. I'm sharing the thread builder. Yeah, here we go. So yeah, now let's go to the next concept, right? Even more fundamental concept before we talk of digital revolution, before we talk of cloud computation, is industrial revolution. So earlier, what used to happen was different people used to make things in different places. But then we started setting up factories and we started making everything in one place. We started setting up factories and we started making everything in one place. Why did we start setting up factories and start making things in one place?
So that everything coordinates for the
Right,
coordination.
Yeah.
To create a production line, see it is easy when things are in one
Also, it's
place.
easier.
Why
Mass,
does it become
mass
easier?
mobilization
Resource
and mass
efficiency is
creation.
better.
Mass mobilization and mass creation.
What happens with mass mobilization and mass creation?
You can build more products.
You can build more products locally also. Different people in different homes can make more products as well.
No, then you
That's
have see, you also have a centralized system that way.
So what is the advantage of centralized system is my question.
Centralized system, when you have a centralized system, you can look through every single thing that is happening. You can have more control over things.
Okay, now let's take an example. It becomes easier.
We can have more efficiency.
That's
Yeah,
what. How is
time
my question?
management.
How is my question? For all of this, how is my question? So now let's take an example of a bakery. Okay. Now let's say Arjun runs a bakery. Okay. And he started one branch. It was very successful. He started one more branch. It was very successful. He went to 5 branches. It's very successful. Now he went to 10 branches, and the next 5 branches are not as good as the first 5 branches. Why? His decoration, everything is very good, but the food is not as good as the first 5 branches. Why?
So,
Accurate and quality.
because food is preparing in 10 different branches, not in the one branches. It means quality control was not there.
Yeah.
Right. So it's very difficult to control quality when you're doing it at a large scale, right? So then what would Arjun say? Arjun would say, hey, I'll have a central kitchen. For all the 10 bakeries, I'll have one central kitchen. I'll make everything in the central kitchen and I'll send it to all of the branches.
That's
So
also very inefficient technically.
why?
Because instead of see, you also have a decentralized system. So what is more important in this case is training of personnel, not creating another centralized system where you would also get transport cost and all that. Instead of that, it is much more efficient to train the person and do it in a decentralized system itself.
Correct. But what if you have a head chef and the head chef can get you great quality of pastries and great quality of everything in the central kitchen? And from there, things can go to the individual bakeries. What if the transport cost is still cheaper than having 10 great chefs in 10 bakeries?
And centralized system itself.
This is exactly where the factory system beats the decentralized model, right? You look at your Pepsi, your soft drink is made in one place and sent everywhere. You look at all the FMCG. Today your Tata biryani, right? So instead of biryani being made in different places, in a factory you make the biryani and you give it to different people and you boil it and you can eat it.
Haldiram.
Yeah, I mean, Look at any
Yeah,
other
all the
FMCG.
big chains.
Domino's
FMCG.
Pizza.
No, Domino's
Also
still
with the
needs to get their own
decentralized
locations.
with the
Nahi.
decentralized system, we can't also identify where the glitch is happening. It's very difficult to create, matlab, to identify that bug. With decentralized, you have the idea where like one place is responsible for the quality control, and you can guess like everything can be tracked.
Exactly. Your quality mechanism becomes easier with the centralized model.
And even Tarun, I was talking about like their sausage prepares at the one place and then distributes. So secret remains secret.
Absolutely.
Yeah,
Another advantage is your secret, like KFC, right? They talk of secret herbs, or Coke talks of that Atlanta locker secrets.
Yeah, and Oreo also. Oreo.
Okay. So there's a factory model. But one disadvantage of the factory model is you want, in modern day, when you go to a restaurant, you want that experience, right? What if people can customize it right in front of your eyes? You love
like
it?
Subway.
Exactly, right?
Yeah.
You like it if people can customize it right in front of you. So do you want everything decentralized where the final product is given to you in a box at the shop?
No, it
You
depends.
still want to create an experience somewhere, right? So here we go. Here we start the workshop that we split these roles and say, hey, there's my front end where I customize the experience for my user. And there's my back end where I do it's my factory where I do my specialized stuff.
Specialized.
I do my specialized and proprietary stuff in my backend, and I create my experience on the front.
Front end.
This is exactly why we have the specialized roles of front end and back end. So now if you ask yourself, am I a front end developer or am I a back end developer? The answer is, if you are that person who's like the magician, who's like, okay, here we go, and you enjoy creating that experience for someone, then you're a front end developer. But you're that person who is obsessed about quality, who's obsessed about scale, who's obsessed about process, who's obsessed about systems, how to do it in a very neat and organized way. You're a backend dev. You're somebody who wants to do both and you want to start from there till and deliver the experience. Then you're a full stack. But you're not a full stack when you just know how to do both. And it's even, you're a little spoiled to JavaScript because anybody who knows JavaScript and HTML CSS is a full stack. That's the joke about JavaScript stacks, right?
Yeah.
So, but in reality, you're a full stack dev not when you know the syntax of front end and syntax of back end, but when you can operate end to end, when you can manage your factory and also manage your customer. So see, there are some chefs who are very kadus, not very nice. So they can't go talk to a customer. They're only relegated to the back end. There are some people who are very good at receiving the customer and so on, but they can't manage processes. They can't get quality. So they're front end. But if someone can do both, the person is a
full stack
the person is like a leader of the entire operation, right?
manager.
Yeah. I would say more than manager, a leader, someone who can take responsibility of the whole thing and drive everyone to ensure the customer is getting the best.
Okay.
Now, when we talk of the front end talking to the back end, now there are some challenges. So it's not surprising that over a period of time, we humans have come up with an efficient way to manage this. So now let us say Arjun started his, central kitchen, and Shashank is his head chef, and Abukar is the manager of the central kitchen. And now let's say Anuraj is, the truck driver who is going from one bakery to, the central kitchen. Anuraj goes to Abukar and Anuraj asks Abukar, hey, I need 10 pastries. Would Abukar immediately give Anuraj 10 pastries?
No.
Okay, now let's make things a little more spicy, right? Let's say Arjun is a jewelry vendor. Let's say Arjun sells diamonds, and he has 10 stores where diamonds are sold. Abukar is the manager, and Shashank is the one who's in charge of the security. So Shashank would give the diamonds to Abukar. Abukar can hand it over to any of the truck drivers. So
Okay.
Anuraj comes and says, give me 20 diamonds. Would Abukar hand it over to Anuraj? Then
Yeah.
you'd give away
Yeah.
20 diamonds to Anuraj.
No, I mean, you can
No,
only,
you
you
can't.
can only buy it from a store, right? Not
No, but
during
Anuraj is the
process.
truck driver who's to go give it to the store, right? Let's say Shafiq is in a store and Abhishek is a customer. Abhishek goes to Shafiq and Abhishek says, hey, I want 20 diamonds. But Shafiq has only 5 diamonds in the store. So Shafiq sends Anuraj to go get 20 diamonds from the store. So would Abukar give away those 20 diamonds to Anuraj?
No, how can you?
Why?
No,
What's the risk?
there is trust issues.
Yeah, there is.
You want to
He may be-
authenticate, right? You want to authenticate whether this is a valid thing or not.
Yeah.
So you want to take the instruct. So what would you do? You would ask Anuraj to, Abukar would ask Anuraj to get a phone call from
Yeah.
Safi.
It's
Shafiq.
like escape. So,
So only if Shafiq calls up Shashank and tells Shashank, "Arey de do." Give it to him. Then Shashank gives it to Abukar, Abukar gives it to Anuraj, and Anuraj gives it to Shafiq. Now one important question is, why so many characters here? Why so many people and roles here? It's an unnecessary cost to the company, right? Why Shashank and Abukar separate? Shashank can go talk to the truck driver directly, no?
but the truck driver have a very limited scope, right? So he can only, I mean, there is a chain. You can't break that chain.
Yeah,
Why
correct.
can't you?
Mir sir is right. You know, everyone has their own roles in the organization.
Yeah.
Why that
It's-
role? Why can't Shashank talk to truck driver? Why you need a manager called Abukar? Why can't the security in charge
Because
talk to
there are
But
because
one
there are
person-
multiple stores, no? There are multiple stores, and
Yeah.
you know that manager, he has to manage all the truck driving and transportation.
So what is Shashank specializing in?
He's specializing in selling. You know, he's the one talking to the
Not
customer.
selling, he's only managing the diamonds. Where are the diamonds going? Are they safe or not? That's it. Abukar is specializing in the communication between the inventory manager and the driver.
But the diamonds are going to multiple places, right? So there is a
Exactly. So
chain.
there is not only one, you know, guy at the store. There are multiple stores. So there are actually multiple people who play the role of Abukar. In this case, only one guy, that is Abukar, is asking with, what do you call it? What is it? I forgot the name. Shashank, yeah. So Shashank actually has to coordinate with multiple store, inventory manager to, you know, get the diamonds. That's why there are so many
So
characters.
Shashank is the inventory manager who's
Yeah,
managing
sorry,
the overall
sorry.
inventory. He's
Yeah,
managing
sorry.
the different managers, logistics managers who are coordinating the logistics for different stores. Okay. So now, so this is exactly why backend can get a little tricky. So on the server, so now you have a server separate and you have a database separate. So what is the database? The place where you store all the information. And server is a machine where you're running your computation, right? Your proprietary computation. As we said, it's a factory where specialized things like the central kitchen where the specialized things happen. So you can look at it, you can say that your database is like a go down. And in the go down, you have all the important raw material. You take the raw material, you make, and you send it to the shop. Front end, you can think of it as a shop. Back end, you can think of it as your central kitchen. And you go down, you can think of it as your database. So you'd want a special place to store your data, right? And now let me ask you guys a question. What is the difference between a database and storing everything on an Excel sheet?
You can't, from a developer point of view, you can't fetch the data from Excel sheet.
Also, database manages like the data on its own. Meanwhile, with Excel sheet, we have to manually change the data.
Exactly.
Manually.
You can get it from Excel as well. It's like difference between all books scattered and books being in a library, right?
Yeah.
Database is a very structured mechanism. So when it's a very structured mechanism, it's optimized for querying. You don't have to worry about how I store my data. You just have to worry about what is the right database for my
For my data.
because there are various kinds of databases. Depending on your business requirement, you look at the kind of database which you need. Now, one important question is, would you use a SQL database or a non-SQL database? Now, what if you're getting very new kind of data every time? Can you stick to one schema or one pattern of data?
It is not relational. It is
No
not
So
SQL
schema is basically the pattern of the data. Schema means pattern of the data. What in every set of data which I get, what all entries do I get? For example, let's say you're storing the details of a student. So Arjun, age, which state he's from, and so on. So if you know that all the data is the same structure, you can use a tabular form, which is called a SQL database.
SQL.
relational.
But if the data can change, every time, you might want to use a document database or a non-SQL database, so that you have the flexibility to have documents of different kinds, and all documents may not have the same structure.
Same stuff.
So in databases, again, there are different types, and we take a type of a database based on the business requirement, based on the nature of data. So what the server can talk to the database, the server can get the data from the database and then do the computation and give whatever is required to the front end, and only on a need to know basis. What happens when we give everything onto the front end? The secrecy is compromised, right? You said proprietary data, like secret herbs. You don't want to tell what that herb is. You only give the chicken to the front end.
Privacy will be affected.
Right? You only give what is required, so that you don't put too much load also on the network. You store too many things as a load on the network, right? You store too many things as a load on the network, right? I mean, you're sending too much, so much of bandwidth is consumed. So what is happening? There's a database, there's a backend. The backend talks to the database, but you need a mechanism for the client to call the backend, right? For the mobile which you're using, it has to be able to talk to the, you want it to talk to the server. That is, you want the store to be able to talk to the factory. So that is where we use something called an API. An API is a link between the client and the server. But there's a difference between an API and a socket. So if it's an API, the client can talk to the server, but the server can't always talk to the client. Now, let us say, you're buying from some website. You're buying from some website. That website always has access. That website always has access to your mobile. Is that problematic?
Yes,
Why?
because then all the unnecessary, like the information you don't want to be shared will be shared every time, and you don't want it.
You don't feel safe.
Yeah, it's the
Our
breach of
privacy
privacy at
issues.
times.
The
Security
privacy
is
is compromised.
Yeah,
Privacy is compromised. They can spam you.
yeah.
So would you want your browser and your operating system to give you that assurance that people can't talk to you whenever they want?
Yes,
That
always.
people can talk to you only when you give them permission?
Yes.
Yeah.
So the moment your that website sets up a socket with you, it means for that entire session you've given them a permission, and the server can talk to you consistently. Like, let's say when you open a WhatsApp, right, and you have a WhatsApp group, and Arjun has sent a new message there. Your client refreshes the session there, so that the data which Arjun sent comes to you, because otherwise you have not requested a latest update. No, do you guys get what I mean? You're opening your WhatsApp, you did not request to give me the latest update, but because the server has a continuous communication with you, the server says, hey, we've got an update, so take this. But if I don't have continuous communication, the server has to wait. When is Akansha going to call me next? Then I'll go tell. It is like saying you're a spy, you're operating in Pakistan, right? And I am the server, which is Indian, let's say, NIA or RAW or one of the agencies in India. I wait for you to talk to me, and only then I can tell you what to do. But if I have a socket, which is like a satellite phone between you and me all the time, I can talk whenever I want. Otherwise, I only wait for you to talk and then I tell you what to do. Do you get the difference between API and socket?
Yeah.
Socket, yeah.
Yes, yes.
With
Yeah,
API, me as a server, I can talk to you only when you decide to talk to me.
Socket is two-way communication.
Yeah. Two-way, and that communication is intact for that entire session. That
Hmm.
API is event-based communication, right? When that event is over, that API ends. So Amrit is saying request-based. I'm saying it's event-based. Adarsh is saying, yeah, real time is the socket, but API is event-based. Now it's important for us to ask, why did we make these two mechanisms? Because a lot of times I would want my communication to be event-based, because otherwise maybe the company can spam me, the company can invade into my privacy. But for certain applications, I may want to give the permissions and I may want to have continuous communication. Yeah, Google Maps would want continuous communication so that they can guide you. So there you allow sockets or pipeline, which is Kafka, something like that, right? So we spoke of separate DB and separate server. Then we spoke of from client to server communication. We can have an API, or we can have a socket, or we can have a pipeline. Pipeline is faster. Pipeline is different from socket because the socket gets reset after every session. The data is lost, but if it's a pipeline, the data is not lost. Okay, so there are three different modes of communication: through pipeline, through socket, and API. So again, we've made different mechanisms for different use cases. Now there's a controller on the backend in the server. The controller actually talks to the database, performs the computation, and then the controller gives the data, and then the API takes the data from the controller and gives it to the front end. So how does a front end access the API? Through an AJAX call, right? I mean, that's one way. So through an AJAX call, the front end can access. So the API is something which is sitting on the back end. So through a network call, the front end can access a program which is there on the back end. So imagine there is one PC which is your client PC. There's another PC which is your server PC. So your client PC can access a code on your server PC through the network method. One network method is AJAX. Once it accesses it on the server PC, then but again there you hit a route. A route is like a door. Why do you want different doors? It's like, you go to a bank and you have different counters for different things. Why do you want different counters for different things?
For time efficiency and managing.
Because different counters specialize in different requirements, right?
Better
You
optimization.
know
can
where to
filter the-
get the data from.
Because each one is specialized to do the task. So likewise, when you write your API, with a route. And this kind of each kind of request goes onto a different route. That's like a counter. So they hit that route. Once they hit that route, first a middleware comes in and the middleware checks, hey, is this a valid request? Now, let us say, again, you go back to the central kitchen and let's say Abukar is a manager and Shashank is the one who is the chef who makes the food. Now, some random person comes and asks Abukar, hey, give me pastries. Would that random person be allowed to talk to Shashank directly?
No.
Why?
Because he is the manager, and the person who is coming only will go to the counter and ask to the receptionist.
So would Abukar also talk to this person directly, or would there be a receptionist who's first checking and then sending to Abukar?
There will be a middle person.
He can.
The middle person is Abukar between the chef, but even with the middle person, there's probably a receptionist who checks the request. No, if the request is valid or not, because otherwise you're wasting Abukar's time, right?
Yeah.
Because you don't need somebody as specialist as Abukar to go and check the request. Somebody more basic can check the request, like a receptionist. So Abukar is like the controller. Shashank is the database, or maybe Shashank could be another little controller, which is a method which understands how to do that really well. The middleware is like the receptionist who's checking. Now the same receptionist can check multiple things, no? If the receptionist knows how to check things. So what we do is we write middlewares. Middleware can check, is this user logged in or not? So you have different middlewares, like is this user logged in? Does this user have the permission for this? Usual checks, right? Usual checklist. So the usual checklist, you have different middlewares. So when you set up your API, what do? You just attach the relevant middlewares. Why does it become easier to write this code? Because all you have to do is you have to check with your checklist. What all checks do I add here? So your possibility of forgetting the checklist is
So very dangerous.
less, no? Why is it
Yeah,
less?
very,
Because
very
while setting up the API, you look at your list of middlewares and say which all middlewares do I want to add. Otherwise, you have to manually write the checklist, no?
Yeah.
Is the user logged in? Is this user allowed to access it? All of that. But
Okay.
instead, you make a middleware.
Can you explain middleware again?
Middleware is like, it's like a check which you do to the request, and only if the request is a valid request, it sends the request to the controller.
So it is like an authentication.
Yes. So if you write a usual list of authentications, while setting up your API, you can just check what all authentications do I want to add here? What all permissions do I want to add here? Yeah,
And it is at the front end only. So middleware is basically used in front end. Back end. But then you said, see, you gave the example of what do you call it? That a person coming at the shop and then asking for some set of product. So, and you gave the example of a receptionist doing it. So isn't receptionist supposed to be at the front end? And he's doing all this authentication work at the front
This
end.
is the receptionist of the factory.
Okay.
Your shop sends a driver, which is the API, to the factory. Your shop sends a driver to the factory. And the driver goes to the factory and the middleware checks the request. And the request is legit, then it's sent to the controller. Got it?
Exactly.
If the request is legit, only then it's sent to the controller. The reason is we do not want our server bandwidth to get wasted with unnecessary requests. Because how you pay your server for the amount of computation you use. And a lot of times, the amount of computation you do is a cost to the company. For a lot of startups like Deep Thought, which is in the early stage, or even Gropital, which is in the early stage, you don't buy a dedicated server. You usually buy a shared server. Shared server is cheaper. So if it's a shared server, your server is shared with other people. So your vendor, which is AWS or DigitalOcean or anyone, your vendor actually charges you based on amount of computation you use.
Requests.
Yeah. So if you run your APIs, let's say someone is making a ticket request, okay? They're booking a flight ticket and they don't send all the details. Your API runs the controller. Your controller does all the calculations and then realizes, this fellow's Aadhaar number is not there. So much of computation resources went waste now. Instead, your middleware itself can check, did I get all the details or not? And the controller can run only if the middleware says, okay, this is fine.
Okay.
So we write a lot of middlewares and keep them. So whenever we make any new API, we can just think What all middlewares do I want to add here? What all authentications do I want here? What all verifications do I want to do even before this guy starts running? That becomes a lot easier because see, when you have a list of checklists and you add one checklist to that, that's a lot easier than you thinking of checklist from the scratch every time, no? It's like you have a set of stickers and you're choosing which sticker to add. Is that easier, or you creating that sticker every time is easy? You may forget, no, that I need this validation there. But what if you have a list of middlewares? You just have to look at this. No, not needed. This, needed. Let's add. This, let's add. It's as easy as writing one word there. When you set up the API, you just add, okay, take this middleware, take this middleware, take this middleware, take this middleware, and you're done. Are you guys getting the concept?
Yeah.
So when you set up an API, the API hits a certain route. The route is like a control counter. So on that counter, you go with a request, and APIs are of different kinds. The 4 basic kinds which you look at, you call them CRUD, right? You create a new entry.
Create.
In the database, you create a new entry. That is for the non-technical guys. Let's say in the database, you want to store a new entry, right? You want to store Shashank's details. So that's a create. Read is Shashank's details are available in the database. I want to take it and show it to the front end. Either I create a new entry, or I read that entry and show it on the front end, or I update. He wants to change his name on the backend, or delete. You want to delete a record. You don't want it anymore. So the 4 basic operations are create, read, update, delete. So these are the database operations which the server does to the database. Okay. So now let's draw a diagram. Let's draw a diagram to understand the backend. So here you have the front end, the client. You do a network call. You access the API through the network call. And you hit it on a route. And there you have a middleware. The middleware checks your request. Your API goes with a request on a route. So with that request parameter and a route, it goes and hits the server. On the server, the middleware checks the request on the route, and it also knows the type of the method. Is it get, put, post, or what? Forget the get, put, post. Which type of CRUD it is. The type of method it is, the route, and the request. It gets all the 3 information. That in counter number 15, they want information. What do they want? You understand what type of a request it is, because the permissions you want for read and the permissions you want for write could be different, no? Let's say you're an LMS. A student is saying, please go write the marks into the database. What does the middleware say?
You are not the administrator.
Bye-bye, right? The middleware says, hey, you're not allowed to write marks. The student comes and says, all right, tell me my marks. The middleware says, okay, fine, go see your marks. The student says, hey, send me Shafiq's marks.
No.
The middleware checks the fellow who's asking the marks, and the marks which are asked, are they both the same? They're not the same. Is this person an administrator? No, so not allowed. So the kind of permissions you have for read and the kind of permissions you have for write, would they be the same? So before I check whether you are permitted, I'd want to know what kind of a request it is. I'd want to know what kind of a request it is. I'd want to know what is your specific parameters of your request, and I want to know which counter you have come. Then me as a server, I'll call the middleware. The middleware would check, and the middleware says okay. If the middleware says okay, then I go to the controller. The controller can call more controllers, or it can get something from the DB, from the database. Then it performs a computation. and the controller then gives back the response to the front end. Okay, so this is how the mechanism works, and we also have codes like 404 and so on. That status codes basically is a communication between the front end and back end. Ki bhai, hey, this request went well, this request didn't go well, and so on. Why do you want those codes? Generally, why do we use such codes or sign language? Let's say you're talking and I'm a moderator and I'm like, what do you
Yeah,
understand?
so that
More specific.
When I say
codes
this, what do you
are-
understand?
Time
Out.
break, time out.
Your time is running out, stop your pitch and so on, right? Why do we have such codes?
to be more
It has-
precise, while at the same time other people don't understand it. Maybe.
No, here it's not secrecy. Yeah, Niraj.
Means front end part front end developer can understand the exact meaning of the code.
Yeah,
Like
front
it,
end can understand that code much faster.
Hmm.
You need not write detailed thing every time. Just write a code and front end understands. Acha, that request was successful, request was not successful. So there are various things which could have happened when I sent a request. So the status code tells me what exactly happened.
Yeah,
So
we
now,
can.
now let's look at our Maya Jal again. Let's look at our circus. So this is a circus, right? The front end makes a network call. It hits a counter with the type of the request and the request parameters. Then the middleware goes and the middleware checks whether the request is legit or not. Because I do not want to have my resources used if it's not a legit request. And the kind of request can change based on the parameters sent in. Then the controller runs the business logic, the specialized expertise, right? My specialized way of making pastries, all of that happens there. Then the specialized methods happen in the controller. And then the controller might call other controllers, might call other methods, or might access some information from the database, right? And then the information is sent back to the front end. The front end uses that information to serve the customers. This is the entire system. Now the system might appear complex, but all you do is the front end developer anyway does the integration, which is the front end developer uses Ajax to call an API with a route. What does a backend developer do? Write a controller, create a database, and write a controller. Initiate a database, write the controller, then write the middlewares and set up the API. That's it. Create the database, create controllers. Then you set up APIs. How do you set up APIs? You say that on this route, if I get this kind of a request, please use this middleware, and only after this middleware is run, call the controller.
Yeah, after the authentication.
You understood what I'm saying? How you set up your API? You set up your API saying, on this route, if I get a create request, please run this middleware first. If this middleware authenticates, then run this controller. That's how you set up your API. Your API is basically your standard operating procedure in terms of if someone comes to this counter, how to accept them. That is what I'm saying. Counter number 15, all student requests come. So if a student request comes, if the student is only asking for reading marks, you check if the student is allowed to read the data or not, the middleware. After that middleware is done, then you please call the API called Shashank, who will actually get the marks and give it to the student. So what are you doing when you set up the API? You're saying, okay, you listen to this route so that the API knows I'm constantly listening to that route. That anything which is coming on that, code, on that counter, anything which is coming to that counter, I listen. So that on the server, if anything comes to the counter, that server goes and tells this API. Then the API is like, hey, let me first run it through my middleware. The middleware checks it. The middleware says, okay, fine. Then the controller gets called. Now, writing the controllers is just like normal programming. You write a normal method, and that method goes and does the task. So writing normal programming is never a challenge for an intern or a beginner. The challenge is understanding how to design the system. Because so many people are using, there is secrecy, there are so many considerations coming in. So we designed this system for all the reasons which we discussed in today's workshop. Now, another thing we do in backend is we try and ensure that not a single line of code never crosses 200 lines. Because when it crosses so many lines, it becomes difficult to understand. So what happens is you might write different methods, right, to do things. So you can write that methods in a different file and call that function inside this function. Now that is called modular thinking. We'll have a separate workshop on modular thinking some other day, but modular thinking is I organize things in packets. It's like I organize all my data in different rooms. I don't keep everything in one room. It's messy. Like a library.
Like Java does.
Right? Huh?
Like Java does.
Exactly. Any software does. Organize things in careful libraries. So you don't have all that code in one place. So it's easier to navigate. So when you understand any backend code base, the first thing to understand is to understand the folder structure. What do they have in different places? So you'd want to understand, first you'd go and see what all APIs do they have. Then you know, okay, these are all the places, these are all the ports they're listening, these are the requests they're listening. What are the middlewares? What are they checking? What are the controllers they have? So then your backend code base becomes less intimidating. Because you know which one is which piece and why they're there. You know where to look for which piece. Do you understand what I'm saying? Because the entire system is there. Now you want to know where to start understanding the system. It's like when you guys came into deep thought for observation, there were so many things happening and it was already very efficient and you didn't know how to understand. But eventually you found your logic, no? Okay, in this room, this happens. Okay, this person is a product manager. This person does this. Okay, this person is a developer. This person does this. Okay, if a developer and a product manager are meeting, matlab it's a brainstorming session. Let's go there. You slowly found mechanisms of how to understand, right? In the same way, when you take an existing code base, you can have mechanisms to slowly understand what is going on. How you might want to look at all your APIs. When you look at all your APIs, you understand what all requests is it listening to, what all middlewares are being called. And when you're understanding a new code base, would you want to spend time understanding the middlewares? Initially, I wouldn't understand.
Specifically not.
I'd try to understand what requests are coming, what controllers are being called, what DB operations are happening inside each controller, and how is every request handled. So you look at the place where all the APIs are set up. There's one place where all the APIs are set up in the code structure. Then you see what is the traffic coming in, right? Traffic, what requests are coming in, what response is going out. So then you see this API, what controller is it calling? So you see what requests are coming in from there, right? You understand, okay, these are the requests coming in. Then you look at what, controllers are being called. Then each controller, you see every controller has a request and response parameter. So there you understand this guy has this input, this guy has this output. He takes this input and he gives this output. Then you want to understand inside that controller, what are the controllers are called? Because this controller might take help of other people. It's like Shashank is a controller. Shashank might take help of Abukar and Shafiq. So then you draw a mind map of different controllers, and each controller you draw a mind map of what is the input, what is the output. When you understand modular thinking, you can understand folder structure really well. So one very important thing to be a good backend developer, to understand an existing code base, is to understand that flows of functions, right? How different functions are working as a system. But today, I didn't want to go into all that detail. I'm not going into folder structure today. Some other day we'll go into folder structure and modular thinking. I think I already have this workshop, reading code like a story. You go through that, you get some pointers there. But today I'm just talking of the entire backend universe, how this system works, right? So with this, I conclude my workshop and I'm happy to take questions. Over to you, Abukar.
Yeah, I would like to know how this node DB is helping the data in terms of backend
and also I see some PIDs and TIDs. I actually understand a small bit information about it. What is this IDs are passed from front end by the node BPX? What I want to know.
Sure.
Yeah.
So in Deep Thought, we use an open source database, open source code base called NodeBB. Okay. Now, usually one thing which I tell a lot of startups, is if you're a startup, it's a suicide to write the entire code on your own. It's literally an operational suicide. Because you see, designing a system is tough, right? It takes a lot of time to design this complete system. You're putting so many checks and balances and you're designing an efficient system. So what if you can take one system which is very related to what you have and start adding your functionalities to that system? Would that be easier? Whatever authentications you need already exist in the system. So your entire structure exists in that system. You only add your specific features on top of that system. So one very important thing which a lot of good startups do is they don't try to write code from the scratch. They try to take an open source database, open source code base, and they modify the open source code base to meet their requirements. And that's exactly what Deep Thought did. We took an open source code base called NodeBB and we modified NodeBB. And today we modified it so much that NodeBB also wouldn't recognize that it is NodeBB. Because we've been modifying it for 1 year now. But when we started, and you know what happened? We were working only with interns. We didn't have too many experienced developers. We didn't have any experienced developers, unlike GrowPetal. But our interns were able to just handle backend. Industry was shocked. How are interns able to handle the whole thing? And we said, it is because, we are, of course, me and Hariharan were there to look at me for the product, Hariharan for the overall tech structure, Mr. Hariharan was our CTO. But no, or whatever developer was an intern then. So he's still learning. Because the structure and the system was already there, very neat system. He was playing with the system and understanding the system. So our developers could learn very fast because they could learn by playing with NodeBB. So Abukar, if you're a backend developer, you're dealing with a very efficient system. Sometimes you make it so complex. But Abukar, let me just give you one little advice. As a backend developer, when you look at a good system, have some gratitude. Have some gratitude to NodeBB. Why do I say have some gratitude?
Life easy करता है. It makes our work easy, like more easy.
No, I wouldn't say that.
Rewritten code.
Because somebody has done it for you already.
Yeah.
You'd want to have gratitude that somebody has done this for you. The moment you have that gratitude, you start understanding what that person did for you. Then the whole system you start understanding, then you can start using the system. See, please understand one thing. Anybody can write a code from the scratch, but it takes maturity to work on somebody else's code base. You're a really good developer when you can access somebody else's code base and work on it. Lot of good developers struggle when they have to use somebody else's code base and work on it. But in reality, you work for a large company. You have to work on somebody else's code base. You can't be that, Rajnikant is going to do everything by yourself. So Abukar, I think why we use NodeBB is this, because they've already figured out a lot of things. We don't want to reinvent the wheel. So we want to spend our time in realizing our functionalities. Our specific functionalities like thread builder and all, which we know really well, our product. We want to spend our time build the product, not the infrastructure. We want to build infrastructure only if it doesn't currently exist. Any company, it's a waste of your time to build the infrastructure. Rather spend your time building the product, because if you're a startup, you don't have so much money. Quickly go realize your features. If you're GrowPetal, quickly go realize your features. Don't go make infrastructure. Copy paste the infrastructure which is already there somewhere else. So now when it comes to TID, PID, so Abukar, how would you understand? With gratitude. You would understand why do they have TID, PID. So which means in NodeBB is a publishing platform. In a publishing platform, they have topics and they have posts. So they have a library already. They have a library system already. So we don't want to create a library system. We'll use their library system, which is there's a topic. Under a topic, there can be subtopics. Under subtopics, there can be posts. Under posts, there can be subposts and so on. So there's a nesting structure, right? So now in deep thought, when we want to create something, let's say in the discussion room, we're creating something under a thread. So to the thread, we give a TID. And to the thing we create under the thread, we give a PID. So we say that the thread is a topic, and we say the things under a thread. Let's say, to a thread, Abhishek is going and giving a smiley reaction. I love this thread. Or Shashank is saying, I want to add a comment to this thread. Those are all posts under a topic. We are using the structure which NodeBB already has instead of creating our own structure. So TID, PID, Abukar is basically parent and child structure. So now people, when you look at your own backend structure, whatever backend structure Gropital has or Kringle has or anything, you want to understand why they have that system. So then instead of creating your own system, you can reuse the existing system and play with it to avoid a lot of coding. In deep thought, our entire data, we treat it like a blog. Why? Because our NodeBB already has systems for a blog. So we treat our data like a blog and send it like a blog and play with it like a blog. It's not a blog, but we treat it like a blog. Why? Because we already have machinery to treat it like a blog. It's like, let's say, Abhishek is my chef who knows how to cut a carrot. I've got a radish. Abhishek doesn't know how to cut a radish. I tell Abhishek, this is also a carrot, it's a special carrot, cut it. Why do I tell him that? Because he already knows how to do it. I tell him this and get him to do it. That's why we are reusing the TID, PID concept of NodeBB, because they already have it. Use it. Why do I want to reinvent the wheel? See, if you're a developer, your life is messed up enough. You're a developer, your life is messed up enough. You don't want to create more trouble for yourself. So if something already exists, what do? I use it instead of trying to reinvent the wheel. These are all things of how you mature as a developer. It's not your syntax or technical skills. It's how you mature as a developer, your decision making. These are all mental models you want to have better decision making as a developer. Now you understand why a product company developer is different from a service company. It requires more maturity. It's more psychological than syntax or computer science. Next question. Abukar, does it answer your question?
Yeah, you answered my question. Thank you.
And I hope next time you get a question, you can use the same approach to understand.
Yeah.
Look at the system, why they have the system, and see where else can I use the same system. I know how to cut a carrot. Can I also cut a radish with the same cutter? Yeah.
Making work easier.
Exactly. So I don't have to do unnecessary coding, right? Unnecessary thinking also. I have enough thinking to do. So if I have something already, let me go do it. I'll spend my time thinking on those things where I don't have something already. I make my life easy. That's what developers are doing to the world, right? Making the people's lives easy by making things in a very systematic manner. Software makes the world very systematic. And of course, it's a no-brainer that when software can make the whole world systematic, it makes itself even more systematic. So if you learn to be a good software engineer, you can be good in so many things in the world because you learn how to do things in a very organized way. I'm a computer science student. I'm a theoretical computer science student. I don't code, but I take the approach of computer science to other things which I do, growth hacking or, teaching, curriculum development and so on. Because computer science is a way of thinking. It's a very organized way of thinking. You can take that to different places. You can take it to politics. You can take it to administration. You can take it to so many things. To organize the world in an efficient way and to make sure people have better lives. Next question. Come on, people. Shoot questions. Come on, people. Shoot questions. Developers never hesitate.
I have one question. When we discussed about MySQL and non-SQL, the only difference difference I got was, as in one you can make changes for the future. Like in the future, when you want to make changes, you can do that. In one, you store the data in tabular format, and like that manages the data. So why don't we use only the one which have the possibility for us to make changes in the future? Because
what if you know that your data doesn't change at all? Why do you want to allow the data to change?
But then what is the harm if we leave it for the future that we have?
Okay,
Like,
let us say that you're taking student details. If there's a deviation from it and you standardize it, what happens? You throw an error. You're not even allowing it to do anything else because you know that you have that system, right? We have standardization in the world, right? You can have that standardization so that things are in a very neat manner. It's like how you index things in a library for the books. You have a standardization, everything is indexed in the same way. You're not even allowing it to be done in some other way so that it's systematic.
It's like in banking system, there is accounts and means detail of the customer like accounts, credit, and all things. So it is in the I think SQL. But when it comes to like what to say the startups, they don't use that SQL. They use no SQLs. Am I right?
Yeah, SQL and non-SQL. So
See, if you have a non-SQL database, it is not standardized at all. Then how do you extract data from it? If it is not standardized,
you do queries, right? That's
yeah,
where it gets tricky. It gets tricky, but you do a lot of queries and get and then
exactly. Plus, you get very different types of data formats, and then it becomes very difficult to work on it.
SQL databases are easier to work. But
and then does it stay intact while we make changes like afterwards, and then also it stays intact the way we are getting the data actually?
Of course, you are the one who will change it, no, with your CRUD operations. That's how you define your CRUD operations, right? You define your CRUD operations in a very efficient manner so that you don't tamper with the database. That's why your middlewares and stuff, right? So you know what is allowed in the database, what is not allowed.
And how do you work with non-SQL databases? It's not standardized.
So yeah, you write queries. So that's why non-SQL databases, your structures become important, like this TID, PID, which I told Abukar. You index your records very carefully. Okay, I'll give you an example, right? Sorry, just one moment. Yeah, let me give you an example. In Deep Thought, we're working on a feature called discussion room. Where people can have asynchronous discussion. In the discussion room, we are letting people celebrate somebody's idea. We are letting people spot an insight. So what happens? Let's say Arjun writes something. Abhishek can spot an insight and say, I've spotted an insight, and write something under Arjun's thread. Let's say Arjun says, I completed the project today. Abhishek can go and celebrate Arjun's success. So now we are creating a reaction to a thread. Now every reaction, we are storing it as a separate document in the database. Now when we store it as a document, we are storing different information. One is the creator, the source creator's UID, user ID. That is the ID of Arjun, who is the source thread. Then the reaction thread user ID. That is Abhishek's user ID. Then the topic ID, the ID of the source thread, which is Arjun's thread. Then the post ID, which is the ID of this particular reaction we are giving there. And also the ID of the discussion room in which this entire thing happened. So when I take any new document, I know in which discussion room it happened, under what thread it happened, and what is the ID of this particular reaction which I'm creating, who was the one who triggered it, who was the one who reacted. So now if I go somewhere else and ask, I want all the reactions which Arjun got from people. I write a query and I say, hey, for the source UID of this, show me all the reaction documents. Or I want to know, in the last 1 year, how did Abukar behave with Shashank? I say, for the source user ID Shashank, for the reacting user ID Abukar, show me all the documents.
So we use query to turn non-SQL databases to SQL databases.
You could say that, yeah. You could say that.
All right. All right.
But that becomes difficult because every time you have to go and run that operation.
Yeah, I mean, also it becomes very difficult to understand the whole system if you have the whole database. If you have a non-SQL database.
That's exactly why, you know what, Arjun, what happens is in a lot of large organizations, you have both SQL and non-SQL databases working in parallel. So your data might come into a non-SQL database and get stored, but there could be analyzers working in the backend which are organizing this into SQL databases to get efficiency in computation. So that's why if you're a good backend developer, it's very important for you to understand the systems thinking, to understand system design and so on, because you design systems which can do all this efficiently. Because that's where the monstrous work is happening, right, on the back end. You're organizing all these things. That's why it becomes very exciting as the system gets bigger on the back end. Does this answer your question?
Yes.
Akansha, does this answer your question? So we use a combination, I mean, as the organizations get larger, but as a startup, we tend to use MongoDB, which is a document database, a lot of them, because I'm like, optimization, let me get large. For now, I want to release my product. I want to make sure people are paying for my product. I want to make sure my investors are convinced with my product. Then once I get enough resources, I'll start optimizing it. When you're initially in the creating stage, then you go to the optimizing stage. Okay, next question. You have time for 2 more questions. Who's going with the next question?
Yeah, I want to ask. You said 3 things about controllers like API, sockets, and pipeline. Can you please more elaborate this word pipeline?
So see, a socket, right? The data gets lost after the session is done. Like if you refresh your browser, the data is lost. But if it's Confluence Kafka, you use Confluence Kafka, the data is not lost. You hold the data even if you refresh the browser.
Confluence Kafka.
That's one way of a pipeline. KFK. I don't know what WhatsApp uses, but Kafka is one way, and it's a lot faster.
So it's like when you are doing a video call on Zoom, and then when you reload the web page, instead of going to a blank screen, it comes back. It comes back to that video call. That kind of thing.
That could still be from a socket, right? Maybe you're getting the data from the backend.
Okay.
But if the video call data is only coming from the front end, then that could be a pipeline. Yeah.
All right.
Or I don't know, they could be using some local storage on the client's end and using the temporary storage to run it. See, basically, let's understand it philosophically, right? Philosophically, what are the 3 structures? One structure is event only. Your client triggers an event and then the connection is set up. After the event is over, the communication is over. It's like you want to buy something on Big Basket. Your mobile is talking to Big Basket only when you make the transaction. Beyond that, Big Basket is not allowed to talk to you. Big Basket wants to talk to you, they will send you an SMS, email, or whatever. That is event-based communication. Now, another thing is session-based communication. For that entire session, you're having connection intact. You close that session, it's gone. And you refresh the session, the data is gone. You don't want the data to hold beyond the session. The third one is a pipeline. That pipeline is intact as long as you're using that application. But even if you refresh or there's a internet bandwidth issue and gets disconnected or something, the data is still persisting. So in those cases where you do not want the data to persist, you can use a socket. But those cases where you want to hold the data, with the user, then you probably use a pipeline, right? Like Kafka.
Tarun, could you please give me an example of like you were saying session-based thing like we just lost data when session ends. Means, is there any example?
Let's say you're booking a ticket on IRCTC.
Mhm.
Let's say they use sockets. And on your front end, you're entering some information. And your internet got disconnected. The page gets reloaded. You have to enter that all over again, right?
Form submission.
So they are using sockets. Means this kind of technology means we
I'm
can.
not saying they are. I'm not saying they are. I'm saying if they are.
Yeah, means I know like a session thing, but you were saying na, like sockets, we just lost the data on the refresh, and sessions we lost the data on the reload.
No.
Means
If you want it to be
session
session
ends.
specific,
Yeah.
socket
Yeah.
can make it session specific.
Hmm.
But when you have a pipeline that's continuously interacting, even if the session is you're refreshing or something, it still processes the data.
Okay.
So when does it end? When does the pipeline, completely ends the?
I'm not fully sure, but I'm guessing it could be something like when you close the browser, it ends, right? So probably holding for some time.
What session?
The Kafka.
Oh,
Probably, I would want to look it up. We can all look it up. Perhaps it's like a UPS. Power backup for a while, right? So perhaps, I'd want to look it up though. But I understand the fundamental difference between Kafka and socket is this, that the Kafka is continuously, you don't lose the data after the session.
So which company means in nowadays using Kafka means to understand it better? I'm just
let me look that up and come back to you. Because
okay.
in deep thought, we have not used Kafka yet. We plan to start using Kafka. As of now, we're using only sockets and APIs in deep thought. Shavan took one workshop on Kafka. You can take the recording from him. It's just an hour-long workshop. Hey, what was your previous question? I think I missed one concept. The previous question was about SQL, non-SQL databases, right?
It is how.
Yeah, as in if we don't like, why don't we leave it to the possibility? I only ask that what if we have to make changes? We have to make changes in the future, then why don't we just stick to SQL?
Exactly. So there, wait, I think I missed one important concept of backend. I'm not able to recall what I missed. Schema and data model. Okay, this is one important concept I missed. So when you make any document database, when you make any any database, you want to have a schema. Schema is the structure of the database. What are the elements in the database?
Keys, yeah.
Sorry?
Keys of the database.
In a non-technical way, it's basically the structure of the database, right? So what are the various entries which go into the database? There's a difference between a schema and a data model. So data model which you use for an API can be a subset of the schema. Because if there's a response which is going in for a request, right? From the backend, there's a response which is going. You may not send the entire thing of the database. No? See, let's say there's a database of Abukar, which is storing all his information on deep thought. Abukar says, show me my total number of threads which I created in October. I don't want to send the entire information.
Entire data,
right?
Yeah.
I'll just send that particular information he asked. So when you make an API, you design what is the data model for that API. The first thing we do when we make an API is we design, okay, what's the request, what's the response, and what would be the data model. What is the data I want to send? For example, when we're creating when we're making a create API, here we're making a schema itself, right? Schema itself. Key, I want the user who's creating it, the user who was the target. I told you the 5 parameters I want to store, right? So when you create a new database, you think of the schema. Right? And what you do when you think of the new schema, you think of what all possible queries can come in the future. So you make schemas accordingly. But when you make an API, you look at what all information would the front end require. Or what all information, so you look at, first is you look at the structure of your request itself, right? When you make an API, what information would my server need to process this request? Do I make sense? What is a valid input which is coming from the front end? I designed that. And what is a valid output that my front end wants? What do I get as a request? What do I send back as a response? My front end says the name of the user is Abukar and the date when he wants is October 1st. And what he wants is this. That's a request structure. The output structure is number of threads. It's just an integer. That's it.
So you are saying that according to the possible requests that you might get from the front end, we base the whole schema and data model on that.
Not schema. Schema is for the database.
Okay.
For the API, we design the structure of the request and the structure of the response.
Okay.
What kind of a trigger does the front end send the back end, and what kind of a response would the back end send back to the front end? You design that. Then you make a data model, because through the data model, you understand how the data is flowing in from places to places. Because your API needs a data model, right? What data is it going to return? That response. What all data is it going to return? But while creating a schema, Arjun, while creating a schema, you think of what potential queries can happen in the future, and you do the proper indexing. Like you put the proper IDs there so that the querying can happen around that IDs.
So by data model, you mean, how you, what do you say, arrange things into folders, basically.
Data model is you make a data model. Data model can be a subset of a schema. You make it for that particular API.
Okay.
In that API is sending some information, right? What information would that API send? You knowing what all information that API sends. Because once you have the data model, you know that, hey, I need to get this data. I'll go write a controller which will get this data from the backend, and I'll send this as a response through the controller.
So if you want to make some kind of changes to the front end, any kind of change, any kind of functional changes, I would say, then doesn't it become very impractical to use databases to
Backend never changes the front end. Front end takes data from the backend and front end renders an experience based on the data.
Yes, but data model, this whole concept of data model is basically arranging things in accordance with how we get requests from the front end. Correct. So it seems to be a little impractical. See, because the way I have worked with databases, they most of the time they are what do you call it, stored in a very simple and usually consistent manner. Now, by this concept of data model, we are arranging it in a very different situation.
No,
And
Arjun, don't boil the ocean now. You're trying to throw a lot of fancy jargon and confuse yourself. It's as simple as this, right? It's as simple as this. Now, let's say I'm a e-commerce site. Abukar comes and asks, tell me the price of this item. So I get a request. What is a request? Request is, let's say, object ID. Whatever object is asking. Let's say he wants the price of a mobile phone. Right? I get an object ID. That's in my request. So it comes to my backend. The middleware said, okay, go ahead, do it. Then the controller, what does it do? It takes the object ID and it does a query. Query to which one? Let's say a price database. In the price database, it accesses the price database. It accesses, yeah. I think Shafiq has given a good explanation there. So it accesses the price database and it queries for this object ID. Please tell me what is the price. That's it. Go to this database of prices. Get me the document of this object. In that document of this object, for this key, please get me this value. Once you get the value, which is the price, what does the API do? It gives the price as a data to the front end. What does front end do? It takes the data, it may present it. Whether it presents it in rupees or dollars or whatever is front end's headache.
Okay, I got it.
So front end asks the backend, and give me this data, rest of it I'll handle. So when you design the system itself, discuss what data has to come from the backend and how front end. That's why front end backend coordination becomes important. When you make the wireframes and so on. So let's go back with the flow, right? How's the flow? The front end makes a request. Here, the object ID. Then it goes to the route. There, the middleware checks if it's allowed. Then the controller gets called. The controller goes to the database. It queries this particular database. It gets this value. Then it sends it back as a response. So as Shafiq mentioned, the data model is like the structure of the object which you're using in the API, because the API is communicating through an object. What all elements go into that object? So like here, let's say Abukar is like, hey, I want information about this mobile phone. Then you might say, okay, my data model is, I want to know the name of the company which made the mobile phone, the price, then the average feedback this mobile phone got from all users, 3 points. So then once I have the data model, what do I do in my controller? I write my query to get this information from my DB. And I send it as my, and I put these 3 as my structure of my object, and I send this object to the front end. The front end takes this object, it understands the object, because usually the front end and back end talk through something called JSON, a format called JSON. So your data model is kind of defining the JSON format, right? So once the front end gets the JSON, the front end would understand the JSON and give that experience on the front end. But please understand, schema is different, data model is different. Data model is that object which is moving in the communication. Because a lot of beginner developers, one mistake they do is they give the entire schema as the object. So one very nice way to understand how to do this is to design your process flows well, and how to design your process flows well is what I'm going to be teaching in the afternoon workshop from 2 to 4. But yes, designing your process flows well is very important for backend. Okay, now all the front end devs is backend easy.
Seems.
It's almost like your front end, right? You write a controller, all you need is you need the DB operations. If you know how to do the DB operations, you write a controller, and once you write a controller, you write a middleware, you attach the middlewares and you set up an API and you're done. For the basic
Now our challenge is to make database just.
Database operations you learn in 2 or 3 days. CRUD you'll just learn in 2 or 3 days. It's not tough. Now do you guys get why Deep Thought says if someone knows JavaScript, will teach Node.js in just 3-4 days?
Node.js.
Because you just got to understand the overall system, and once you know this is the scope, just go execute it. Okay, now I'd like to listen to your reflections. What are your takeaways from today's session? What are the new thought patterns you got from today's session? Because I know there are people who are beginners, there are people who are not technical people, there are people who are already well exposed to backend. So I'd like to know what the diverse crowd took as takeaways from the session.
First off, I got to know about the whole, from front end to backend. I got an overview of the whole structure, which most of the systems use.
Okay.
And then I also got about the sockets, APIs, and pipeline, and how they are used. And that's it. I think most of it. This is what summarizes it.
Okay. Yeah, Amrit. Amrit, in case you're talking, you're on mute.
Oh, yes. Sorry. So yeah. So I first of all I learned about like decentralized factories and where secrets remain secrets. So yeah. So that
It's not
part.
decentralized, centralized, no?
Yeah. Sorry.
Yeah.
The word. Okay.
Yeah,
Then I learned about sockets. So in sockets, it is just like bi-directional what we say communication where data do not save on the refresh, and in pipeline data do save. And then we learn about middlewares, how middlewares are working in the DT, and controllers, and what is the why middlewares is so important to save the computation, right. And then we learn about how the whole things is working, like first a front end part, and then with routes it will get methods and CRUD operations, and then it will make a request to server, and then middleware at this point middleware work like it will validate like is it authenticate user or not. So it will save computations power. Then it will go to controller, and controller will talk to DB and all operations, and it will get give a response to front end. So yeah, it was a really good session. Means yeah, thank you so much.
Thank you, Amrit. Yeah, Shashank.
Session, I was the 5 years old, like non-tech, like who's trying to understand backend, front end, cloud computing, and I could understand the relationship between the client and the server, and breaking down and getting into real life examples that made things easier for me. So I'm the 5 years old, like I understood everything. So it was a great session for me.
Okay, I'm glad you could understand most of the things. Yeah, who's going in next?
Yeah, I just feel less intimidated now, because earlier it was like everyone would throw all the heavy words and we will understand. Like there is a point where I can align why that's happening. So I just feel less intimidated to to know that kind of ladder I have to climb. Yeah.
Okay. Anyone else?
I learned that like creation is more important than optimization if you're just like starting out. And like full stack is not necessarily that all that the the front end and the back end. It's not, it does, these aren't the two things that include like in a full stack. You need to know other things as well. And I learned the difference between sockets and pipelines. Data does not persist in case of sockets and on client side, and it does in case of pipelines. Thank you.
Okay. Or whichever developers built the system which you're already using, right? In Gropital, whatever system you're using, be grateful to the folks. And see, if you're a good developer, you'd always want to collaborate with other developers. You'd always want to look at existing code bases and reuse, then do everything from the scratch. Because we're like assemblers in some places, right? We pick pieces and assemble them, and we only create things from the scratch where we clearly know nobody has done it before us. And we know we want to do it in our own way, because you can't create everything on your own. So those few things which are very important, only those few things we create on our own. Everywhere else, we reuse what somebody else has done. That humility for a developer is very important. That I can't create everything on my own. The few things which are my specialization, it's like if you're a bakery, right? You can't say that I'll go and grow my own wheat. It's going to be quite tough, right? If you say I'll go do everything on my own.
Yeah.
I'll go and I'll have my own cows and I'll make the milk on my own and then make the cream on my own and then make everything on my own. Could be a little tough, right?
Yeah.
So in the same way, like a developer, we pick some pieces from other people, and the few pieces where we are specialists, we make that.
Yeah, I think that is what all open source is about. I think like the React.js is also open source, Node.js is also open source. So you are using someone else's code. I think that's a great thing.
Yeah, and as we grow as large organizations, eventually the idea is to pay back, in the sense that even we would contribute some code and say, okay, this is open source. And what is the advantage when we make something open source? Our system becomes more efficient because more people are trying to fix the bugs, more people are watching.
Contribute.
Even if it's not contributing, more people are watching it. So you get more usage. For example, if you look at Deep Thought, we put a lot of our content on YouTube. We are open source in management. So what happens when Deep Thought is open source in terms of management? More people are watching, more people are spotting bugs. So the system gets better over a period of time. That's the beauty of open source culture, that you make something democratic. The world will contribute and the world will also keep a watch on it. The system gets better and better with time because it's more eyes watching. That's why it's always a good idea to pick up open source code bases and work with them, because a big community has been maintained.
Yeah, absolutely correct. Means totally agree with you, because if like somebody is watching you, then you will work like, okay, I will work my best. I will give my 100%.
That's not the point, Amrit. The point is, me as a human being, I'm limited. I can't think of all the possible cases.
Yeah.
I give it to 1,000 people. They're thinking in 1,000 ways. So they're correcting a few things which maybe I couldn't think of.
Right.
So it's a power of collaboration, right? In open source, a big community is maintaining it.
just like Stack Overflow means
Exactly.
solid. By the way, I just asked like, what is the fastest means if a non-tech guy comes, then what is the fastest and most effective way to learn code?
I would say first to learn computational thinking, because once you learn computational thinking, programming becomes easy. Then learn computer science, right? How this cloud computing works, why we have these concepts and so on. Once you know programming and once you know computer science, then the third step is to learn the syntax of front end, back end, and can start off. So this I think is the fastest way. Within a month, somebody who was not initiated to coding can become a coder.
Yeah, means you're absolutely correct. Sometimes what we do, we just get into the code and then we do the random stuff, but we don't have any idea like how things are actually working. So yeah, so that's why I just ask like sometimes even I don't know the major things in the means apart from the backend, like how actually things are working. So that's why I just ask. And the one more thing, like I'm learning apart from Node.js, a lot of things like how this thing is working, how this thing is working. Even I will recommend you if you want to go into learn to code, then there is a code like like CS50 means
No.
yeah. So it is a Harvard means provided by the Harvard, and it is free of cost. And the teacher is best in the computer science, so he teaches means really good. If a beginner just comes and he don't know about computer science, then he must I will say must just take this course, so he will get more exposure about the computer science and the field. Then learning will be more easier.
Great. So Amrit, again, I would reiterate my point that computational thinking and computer science, these two concepts I think become very important.
Yes.
Syntax and all other things can come in place as and when you go into projects and implementation. And if you want to grow as a good backend developer, I think strong understanding of computer science becomes important, because eventually it's no longer about what you code, it's more about how you design.
Right.
Design the system. Coding will be
Make
done
your
by
story.
engineers. It's like if you're a great chef like Sanjeev Kapoor, you don't cook. The cutting of vegetables and all your juniors do it. But you design the system. You design the recipe. So when you grow as a senior backend developer or an architect and so on, you no longer maybe coding as much, but you're making systems, you're designing systems and people are implementing the blueprint which you give.
Means that is the exact thing. For example, means it is more about mindset. For example, I was doing like a lot of projects in Node.js, and the problem, starts when you don't know like how to imagine the thing. Like, you don't know the basics, and you just went to the programming, and you cannot like imagine like how these things are working. So the first need I found out, like you just go into the mindset, means like how actually things are working, whatever you are doing right now. Are you getting my point? Like how this
Exactly. So
computers.
I would say more than mindset, the word I would use here is mental models.
Yeah.
You having your mental models of how things work, that conceptual clarity makes it easy for execution. But again, syntax is important, but I'm saying that can be figured out if the mental models are clear. Okay.
Yeah, right. Means more imagination is important in coding.
And
Like
then mental models aid that imagination. Okay.
Thank
So
you.
I'd like to conclude this workshop with just one line. I'd like to conclude this workshop with one line. A lot of beginners get intimidated by the whole system, by syntax and so on. I would encourage all of you to try the Feynman technique. If you can't explain something to a 5-year-old, you don't understand it. You use the Feynman technique, code or development, or none of it would be intimidating. Complicated words can scare us. Complicated words can scare us, but the moment we use Feynman technique, things can become, easier. Yeah, Adarsh, few projects definitely, because all this conceptual thing which you heard, it makes much more sense when you put it into implementation.
Right.
Because while listening, you feel you understood everything. But when you go into implementation, then suddenly, they make a lot of sense. So the best learning is when you put things into, implementation. Yeah. Thank you, everyone. Thank you.
Means